I'm going to go over some parts of the mole set of problems that we have that you've been having for homework. You've had pages 1 and 2 so far, and I'm going to go over page 1 again in this video. That way you can come back and review it. If you were absent, this is a perfect opportunity for you to see what we did in class to help solidify this concept of the mole. And I have this reminder here. I like this little saying that it's okay not to know, but it's not okay not to try. Remember, my motto is chem is try, chemistry, chem is try. So I have to be able to see some effort on your homework and the problems. It is never an excuse for you to say, I didn't know what I was doing. There should always be some evidence that you have tried to use the information that we talked about together in class. Right, so I also liked this little mole guy here because he has SHS on him, even though he's not made by me or anyone here. He's made by someone else, but that's okay. The mole at SHS, I just liked him, so I just put him there. So we are talking about the mole. Let's look at our first set of problems and make sure that you have out your mole heart because we are going to be using him or her or it in these problems. We're going to use that as our reference. All right, so let's start with number 1. Propane has the formula C3H8. Okay, I can tell right away that that is a molecule. And the way that I can tell that is that there is more than one atom there. So as we're looking at our types of particles in our heart, we have molecules, atoms, it could be anything else. Particles is our generic term for chemical things. And right now, there's more than one type of atom present, so I know that that is a molecule. That's going to come in handy in a little bit. All right, so find the molar mass of propane. Well, on my heart, we said this mm meant that the molar mass was what we found on the periodic table. So what I need to see for your work is this breakdown of the molar mass. So I need to see that the first element is carbon. There are 3 of them. And if you look on the periodic table, you will see that the mass is 12.01. And remember that the mass from the periodic table is it's grams per mole of atoms, because it takes a mole of carbon atoms to make up that mass of 12.01 grams. We also have hydrogen, and we have 8 hydrogens. Hydrogen's molar mass from the periodic table, rounding to the hundredths place, is 1.01 grams per mole. When we multiply those numbers together, we have 36.03 grams per mole of carbon and 8.08 grams per mole of hydrogen. So that actually would be helpful for us to spell it out this way or to write it out this way in case we needed to do percent composition, which is something we're going to touch on again. But for right now, they're just asking for molar mass. So I'm going to add up everything together. There's 11, and that is, carry the 1, 44.11 grams per mole. Now it does ask us to report the units in 2 possible ways. So practically, very practically or realistically, we're talking about grams per mole when we look at the mass from the periodic table. But when we talked about isotopes, we also said that we could, to make this simpler, to simplify our masses, we could assume that the masses from the periodic table were AMUs, atomic mass units. So you could also report that as 44.11 atomic mass units. That would be a second way to report your units. Okay, next one. If a propane tank contains 13,500 grams of propane, how many molecules of propane are in the tank? All right, well, one of the things that we said was that you always start with your given value. We are given a number of grams. And so if we are going to look at our hearts, we were given a number of grams. So let's look. Where do we have number of grams? Oh, and I think I have it a little bit lower. So we have a number of grams right there at the bottom. Number of grams. So that means that when I set up my conversion factor, this is my given. So this will be my 13,500 grams. I'm going to have molar mass on the bottom because that's my grams, and I'm going to put 1 mole on top. So that's how I'm going to set up, or initially at least, set up this problem. So write my given, and I'm just going to put a comma in there because it makes it easier for me to tell where I'm at. I can put that over 1. I'm going to multiply that by a conversion factor. We said molar mass in grams, 1 mole. And again, we're going to start doing this to show that this is one long fraction. Just go ahead and connect them all the way. And then to separate my separate numbers, I'm going to go ahead and write a vertical line right there. Multiply across the top, divide by what's on the bottom. We calculated that this was 44.11 in part A. So if we were to stop here, if we were to just do our calculations up to this point, we would have grams cancel out because they're on the top and bottom, and we would have moles as our final answer. What I need to consider is if moles is what they asked me for, and it is not. They asked for molecules. So that means that I have to go one more step. I need to keep on calculating. So I'm going to put moles on the bottom. What do I put on top? Well, if I look at my heart, if I look in my heart to find the answer, what I've done at this point is I've gone from grams, I've moved to the mole, but they want to know how many molecules. So I have to move from here to here. So what I need to do to move out from the mole is, let's follow the arrows. This takes me out of the mole and 2 molecules. So this is the conversion factor that I'm going to use. And I'm going to use this example set up here, where I would have my number of moles here, which would be this unit of moles, 1 mole on the bottom, and Avogadro's number on the top. So that's what I'm filling in here. Let's do that. 1 mole, 6.02 times 10 to the 23rd. Oh, and I have to have my unit. So what type of particles are we talking about? It's molecules. Molecules. Right, so that is your setup. Remember that when you put this into your calculator, you should be multiplying everything across the top. You're multiplying numerator times numerator times numerator. Divide by what's in the denominator. You could divide by 1, divide by this, divide by 1 again. But if you just know that anything divided by 1 is itself, then you really just have one number to divide by. All right, so once you put that into your calculator, then you should be able to get an answer, and we can check that answer in class. But the most important thing is the setup. And you'll see that many times I will give you answers to problems because the answer itself is not what I'm concerned about. You being able to set up your problem, that is what I'm really concerned about. That is what I really want to see you able to do. Okay, and then moles would cancel. I would have a unit of molecules in my answer, so make sure that you have that. And by the way, if you don't have a graphing calculator at home, to do this work, this is what takes most of the time. Do this setup at home, and then if you just need to come in and spend 5, maybe 10 minutes borrowing a calculator from me at school, then you still have been able to get your homework done before class. So you should still be able to do this, even if you don't have a graphing calculator at home. Let's move on to letter C. Convert 4 times 10 to the 22nd propane molecules to moles. Start with what is given. Always, always start with what is given. 4.0 times 10 to the 22nd. Molecules is the type of particle. All right, so what does my heart say? What do I do? In class, we practiced writing whatever our unit was that we started with on the bottom, and we can still do that. We can still put molecules on the bottom, but let me check just for reference and just to make sure. So if I have this right here, if I have molecules, if I have particles, and they want me to go to moles, what do? Well, I just go from particles to moles. So I'm going to follow this arrow here, which means this is the conversion factor that I'm going to use. This is going to be my setup. My given number of particles is here. I'm going to write 1 mole on top and the 6.02, Avogadro's number, on the bottom. So let's do that. Let me move. I'll move the heart up here. Get it out of the way. 6.02 times 10 to the 23rd molecules. And my heart told me that it should be 1 mole after that. Okay? All right, so let's look at, again, go ahead and calculate this. I'm not going to give you the answers. I want to help you through these. But I don't want to completely give you the answers because I know that this is homework. This is something that you need to complete on your own. I'm just trying to help you through it. Let's go ahead and do letter D. Letter D is going to be a little different. You don't exactly need the heart for it. So let's see how we do that. For letter D, they gave us 4.0 times 10 to the 22nd molecules. That was a typo in there. That is supposed to be to the power of 22. And they want to know how many atoms are there. Well, that's kind of confusing because they're giving us one type of particle and they're asking for another type of particle. So this is going to be a little bit different. What we need to see is that the formula for propane was C3H8, and we knew that that was a molecule. If they want to know how many atoms, then I need to see how many atoms are in one molecule. And if we count 3 carbons plus 8 hydrogens, we will see that there are 11, let's use this here, atoms per one molecule. Right? So I can use that here. One molecule has 11 atoms. And there's my setup to calculate that. And that will give me the answer for that. Try setting up 2A. Pause the video, try setting it up, and I will show you what you should have. Go ahead and make sure that if you're not at the final answer after the first conversion, that you go ahead and make a second step on there, right? So hopefully you have this point right here where you have atoms set up on the numerator and the denominator. And one thing I've been forgetting to write is you can write a 1 underneath your given just to make sure that there's a fraction there in case that empty space bothers you. But now that we've set this up, if we were to do these calculations, we would end up with something with a unit of moles. But they didn't ask for moles, they asked for mass. So even though we've moved from our particles, we've moved away from our atoms, we've gone to the mole, we're not done yet because we need to get to grams. They want to know mass. So I'm going to move this way, use this conversion factor to get to grams. So go ahead and set that up, and I'll show you what it looks like. If you need to pause the video, go ahead. When you're ready to do these calculations, you'll see that your unit of moles cancels out, and everything is set up for you to calculate your answer. Multiply everything across the top, divide by everything in the denominator on the bottom, and you will have an answer. When you do B, I just want to remind you, bromine is one of your 7 diatomic elements. And there's a way for you to remember that. Brinkelhoff is one way. Take the atomic number 7 on the periodic table and then shade in a number 7 with that. And don't forget hydrogen. So go ahead and, given what we've done so far, set that problem up, get that done, and we'll see you in class.